So, right. So now recording is on. So, right, one thing I will tell, okay, through online, sometimes there may be some network issues or something will happen. So in that time, right, you don't bother. Within few minutes, I will be right back. Right? Okay. So now I think Pradesh also joined. Okay. So
Morning.
good afternoon, Pradesh. Right? Okay. So now only you are starting the class. Right? So this is your max class. So I want to tell some basic things before starting the class, right? So apart from academic, so what I expect from you, from the students is whether you are 3 students or 5 students or 50 students or 70 students, or maybe always all the people should join the class 5 minutes before the scheduled time, right? So if it is a 12 o'clock class means I will be there by 11:55 itself, right? So I tell all the three of you, right? Anyway, today Anik joined well before 11:55 itself. Sayed also join on time, but for me it's better to join 5 minutes before the class. You have enough time between the classes, right? So first hour finished off by 11:30 itself. So definitely you can able to join the next class by 11:55 without any problem, right? So that is very very important. Just like attending the class in a regular manner, there is a regular class. So an online class also joining the class on time is very very important, right? And keep your mic in mute mode during the class. Suppose if you want to ask anything, you can raise your hand, unmute yourself, ask your question, then I will answer. Otherwise, better you can at the end of the class, I will always ask, do you have any doubts? That time you can ask your doubts, right? And if you have any network issue and if you're not able to continue, right, you can message me immediately, right? But for me, better you have a proper cell phone with you or proper laptop with you. Even if there is any network error, right? You try to rejoin within few minutes. That may happen for me also, right? So suppose sometime power failure may come, network issue may come, right? But anyway, if it has happened even to me, I will rejoin within 5 minutes, right? You through a laptop or through PC or through mobile, right? So you don't bother. Class is always there, right? I will never miss any class. If I make any changes in the class, I will inform your class in charge. Do you know who is your class in charge? Sayed, do you know who
Yes,
is your
sir.
class in
Yes, sir.
charge? Who
Yes,
is
sir.
your class in charge, sir?
Ashok Kumar, sir.
Ashok Kumar sir, right? So always I inform either your HOD sir or Ashok Kumar sir, right? If there is any change in the class. Otherwise, class will be taken as per the timetable. So at present, they put the online timetable as Tuesday and Thursdays. I am taking the class between 12 to 1. 12 to 1, right? So this keep in your mind. So what I expect from you is, right, try to attend the class regularly. That is one thing. And don't cut the class, right? Joining and after 15 minutes vanishing, or joining only in the after 15 or 20 minutes, or joining only in the end, or some people joining in the beginning, then they vanish, then joined at the end and giving attendance. Attendance will be taken at any time in between the class, right? And one more thing I already told to other friends also, try to change your name. Instead of writing D060, D58, you write your enrollment number. You have your enrollment number E20, some enrollment number is there. You put that enrollment number instead of D60 or D58, because all this D section, H section is only for first year, right? So you put your enrollment number and your name. Okay, that will be easy to understand or identify you as a mechanical student, right? So that thing you have to change by next class. One thing. And then I think all of you joined in the Google Classroom. Whether all the three joined in the Google Classroom or any of you not joined so far?
Yes, sir. Yes, sir. Joined, sir.
All the three. Pradesh, you also joined,
Yes, sir.
right? So only one
Yes,
minute,
sir.
I will have one, right? So 1 minute. Right. So since all the three are already joined the GCR, I already posted the syllabus there, right? Surya also. D61 Surya. So D61 Surya. You are a mechanical
Yes, sir.
student, Surya?
Yes, sir.
Are you in the roll call? Because roll call Surya is not the name itself, not
Sir,
there.
yesterday only I paid fees, sir.
Okay.
Yes, sir.
So you have Surya. Okay, I will attend. No, I will add your name, right? But
Yes,
anyway, I
sir.
will
Yes, sir.
write your. But anyway, you have to inform your class in charge sir, and your class in charge sir should update the
Sir,
roll call,
yes, sir. I am
right?
sending email to that, and I already informed, sir, yesterday itself.
Right.
So,
You inform and you also tell, sir, I attended Max class. My name is not in the roll. Please
yes, sir.
add me. Okay. You just also tell to your class in charge sir,
Yes,
Ashok
sir.
Kumar sir. Right?
Yes, sir.
Okay.
Yes,
So
sir.
you also should join in the Google Classroom. Are you joined in the Google Classroom? Surya. Or you
Sir,
joined in
no,
this
sir.
Google Classroom? You joined, right? Because there only I put the
Yes,
syllabus,
sir.
right? Reference
Yes, sir.
book, and I suggested some
Yes,
e-books also, right? So to all
yes,
of
sir.
you, I'm telling, right? So in the class,
Okay.
I will tell all these things, right? You don't worry, right?
Yes, sir.
So you have to refer all these things, right? So as some, okay, you can unmute, you can mute. Surya, no problem. You can mute, right? So just I will tell all these things now. You keep that in your mind. So right from the beginning, right, whether other classes are going on or not, that is entirely different issue. Max class is concerned, it will go on regularly. So you have to study right from the beginning, right? So, but what I expect from the students is basic student discipline. In the class, you have to be attentive, right? Whenever I ask some questions, right, you have to switch on the audio. If it is video is okay, then okay. If you're not okay, you have to switch on the audio and you have to answer. If you are not answering during the class, right, then it means you are not in the class, right? And then attendance will be taken at any time. You have to give the attendance properly. Apart from that, when you enter the class, in the chat box, you have to type your name and number. When you enter the class by 12 o'clock or 11:55, type your name and number in the chat box. That is for your in attendance. And similarly, once the class is over, again you have to type your name and number in the chat box. That is your end attendance. In between, I will take oral attendance. So your in attendance, your oral attendance, and end attendance. All three will coincide. Then one day I will give the attendance for the class. Right? So keep that in your mind. When you join the class, you have to give your attendance in the chat box. In the end, also you have to give your attendance in the chat box. In between, I will take the oral attendance as in the class. Right? So okay, right. So this is our basic things. Now I share my screen. I'll explain one by one, right? Right from the syllabus, right? You just follow all these things. Then I will tell you some basic things in mathematics that you should know uh, before starting Maths 3. Right. So are you able to see my screen?
Yes, sir.
Okay, right. So first thing I will tell you the syllabus, right? I think now the syllabus is visible to you. So the subject code is BMA 18005, BMA 18005, right? So that is the subject code, and your subject name is Mathematics 3 for Mechanical and Civil Engineers, right? Write in full name. Some people only write mechanical engineers, not like that, because this is a common paper for mechanical and civil. So this is your subject code and subject name, right? And you have 5 units for your syllabus. That is, unit 1 is partial differential equation, 4A series, unit 2. Then unit 3 is applications of PDE, then Laplace transforms and Fourier transforms, right? So this is your syllabus. This I already shared in the Google Classroom in the PDF format. You can download it, right? Do you have any? So those who are not joined in the GCR, join, and then you can download this syllabus with you, right? So here, right from the first unit, that is partial differential equation. The important thing is, right, that differentiation is very, very important, because without knowing differentiation, you can't study differential equations. Without studying differential equations, you can't study partial differential equation, right? Because first thing is you should know what is differential equations. Then only you can understand what is partial differential equation. So for that, some basic things are there. Then Fourier series also uses some basic differentiation and integration techniques, right? And third unit is nothing but applications of PDE. So automatically your differentiation and integration methods will come to part in this third unit. And then the fourth unit is Laplace transform, right? It is also based on differentiation and integration. So my advice to all of you is you have to refresh your basic differentiation integration knowledge, basic differentiation methods and integration methods, right? That is differentiation of uv, differentiation of u by v, right? Similarly, integral v, integral, that integration by parts, right? So that type of basic integral differentiation formulas as well as integral differentiation methods, right? This you have to refresh yourself. But anyway, today also I have some half an hour I will give you the basic things about what is differentiation, right? What is integration? All these things I will teach, right? And as far as book is concerned, your reference book is T. Virarajan, right? For first year and for third semester. So you may ask, sir, why is the first year and third semester two books, right? So in this third semester book, that is in book number 2, right? All the units except the fourth unit will cover. So this covers all the units from 1 to 3, that is PDE, Fourier series, application of PDE, and then your Fourier transform. All this covered in this book, Virarajan, Engineering Mathematics. It is available as a hard copy in bookshops. You can buy, or in even Amazon also. This is available as a hard copy. You can buy through online. And this for one unit, that is Laplace transform. That is unit number 4, right? Unit number 4. It is in the first book, right? Anyway, no problem. At least you buy the second book, right? First, this I will give you the notes, no problem, right? If you have, you can buy, right? No problem. Otherwise, I give you the notes. But Virarajan book you can buy yourself. This will be very, very much useful to you, because unless otherwise you are not able to work out the problems by yourself, because now we are in the online mode, right? So you are not coming to the college. If you are coming to the college, means daily you are coming and doing the problems, right? So here that is not possible. That we write in the board, so parallelly you also write in the notebook, so you have some practice. But now it is not possible. So better buy some book and start practicing, right? Suppose if Virarajan is not available to you, you can also buy the next book, Singaravelu book. This is also for transforms and partial differential equations, same thing, right? And there are some advanced books also there, pricey book. But anyway, for me, these two books, if you have Singaravelu, Virarajan, or some books also like biology book also there. So that books you can follow, right? But for me, my preference is Virarajan book, right? So this you keep in your mind. But unfortunately, the Virarajan is not available in e-copy, right? It's not available in e-copy, right? It's not available in a PDF format. So that I suggested in the Google Classroom 2 or 3 that is e-books, right? So I just show you, right? What are the e-books I suggested? You just follow the e-books. Can you see my screen? No problem. All of you see my screen?
Yes, sir.
Yes, sir.
Right. So now I'll show you the GCR, right? So anyway, there itself we can see who are the people are joined. One thing, since I am also the head of the department for the mathematics, right? So sometimes I have some department meetings or university meetings, right? Only that time only I will change my class timings. Apart from that, class will be taken regularly. So far in the class, Syed is there, Anid is there, Sunil is there, but right, other people are not there, right? Those who are not in the list, kindly join in the Google Classroom. So this is the code TH746JW. This code I already put it in the WhatsApp group also. That is secondary mechanical WhatsApp group. I put this code also. Using this code, join the class immediately today itself. After this class over, you have to join immediately, because here only I posted all the materials, right? So here this Google link, the same link will follow for all the classes, unless otherwise if I tell any changes, right? So this is the syllabus I told now, so that I posted yesterday. So if you click here, you can get the syllabus. Then apart from that, I put some 1 or 2 ebooks, right? So why this ebooks means, this ebooks is available as a soft copy. So when I teach through online like this, okay, I can use only ebooks. So I use this book, Transforms and Partial Differential Equations by Sivaramakrishnan Das and Vijay Kumari. This book's very good, and it's equivalent to Virarajan. A nice book. So this book I will use during the class. This book I will use during the class. So if you have Virarajan book, you can use it, or if you are able to get this book. So this book is available in the hard copy, as well as it is available in the soft copy in Amazon Kindle. So if you have Amazon account, you can buy this book. Some 250 rupees or 300 rupees are there. You can buy this book and you can take it as a e-book, and you can refer it, right? So, and you can download it in your mobile and your laptop also, no problem, right? It is available in the Kindle, Amazon Kindle, right? So this is one book, and another book also there is this is also a nice book. It's also transforms some partial differential equations, right? So Subramanian and Ramaswamy, right? But anyway, the first book I have shown, that only I am using for my classes, right? So, but still I have a ready-made notes for you, right? So you have this PDF file. So this is not my notes, but anyway, fortunately I got this notes last year during the pandemic. I just searched. Luckily I got this PDF file. So this PDF file is a nice PDF file. So here also, except that Laplace transform, your unit 1, 2, 3 and unit 5, that is PDE, Fourier series, application of PDE and Fourier transform. These 4 things are already there in this book in a very nice manner. So here you have a step-by-step workout is there. So you can use it for your practice purpose. Only extra thing is here, Z transform is there, but Z transform is not in your syllabus. Laplace transform is there. So for that I will give a separate notes. Don't read Z transform. Z transform is not in your syllabus. You have only Fourier series, Fourier transform and Laplace transform, right? So you can use this notes for all the 4 units, right? For your reference, right? So all these things why I am giving right from the beginning, because pandemic situation, right? So whenever if you have a time, you can open this book and you can read. There's no need that only I am taking the class, then only you can read that particular topic. Not like that. You can read yourself if you know basics, differentiation and integration. If you know basic differentiation and integration, you can always do your workout problems in Max 3. Right? Max 3 is not difficult. People may say Max 3 is difficult. Max 3 is not at all difficult. Particularly Max itself is not at all difficult if you study in a regular basis. Right? If you give some time to the studies, and you have to study in a proper manner. If you do that, definitely you will get what I say, good marks in your M3s, right? So where did the boy gone? Anit is there, Surya is there, Syed is there. That boy, where is that boy? Who is other boy? Join. Pradesh.
Surya, sir.
Surya. Yeah, Surya is there, okay. Okay, Surya, okay, right. But anyway, one of them is not there. Who is not there? Right, so I put attendance for Syed, Surya and Anupit. Can you see my screen? Can you see your name? Syed,
Yes,
can
sir.
you see your name?
Yes, sir.
Where
Yes,
is
sir.
your name? It is
Sixth.
serial number 6, right? I can put present for you. Right? Anit, can you see your name? Anit? So I add number 7 as Surya. You tell your full name.
Sir, B Surya, sir. Suraya.
Suri
YA.
Riya D.
Initial B, sir.
B. Yeah.
Yes, sir. Yes, sir.
Right. Right. So all three of you must give your attendance at the end of the
Yes, sir.
class. You have to type your name in the chat box. Anit,
Yes, sir.
Syed, and Surya. All right.
Okay, sir.
Okay.
Yes, sir.
So don't think this is the attendance right, but at the same time you have to give your attendance when you start when you join the class. Similarly,
Yes,
when I
sir.
say class over, before leaving the class, you have to type your name here. Do you see the chat
Yes,
box
sir.
here? You just type just like
Yes.
me. If
Yes.
I'm just
Yes,
my
sir.
name is Johnson, I just type Johnson. Okay, and if you have a number, you can type the number first, and you can type your name. Right? So then
Yes,
it
sir.
is easy to understand. Okay. So now, so you, so do you have any questions regarding subject, syllabus, or if you want to ask anything? Because now I am going to the subject. Right. Before that, do you have anything to ask me? You can ask. Timings, you know. Max class timing is Tuesday and Thursday, 12 to 1. Syllabus you have, right? Surya, if you join this year, you will get all the things. Do you want to ask anything to me? Any doubt you have?
No, sir.
Right?
No,
Google
sir.
Meet link, same link, you can use it. Still, if I change the link, I will inform. Otherwise, you can use the same link for all the classes. Right. Okay. Right. Now I will start the basic things. Before starting, I will show you that book which I want use. Right. In the right. So this is the book Transforms and Partial Differential Equations. Right. The ebook what I have shown. Right. In the GCR. So this is a nice book, right? If you are able to buy, you can buy this book, right, in the Amazon Kindle. If you buy this book in Amazon Kindle, it will automatically added to your library. See, this is my Kindle library, right? So I already buy this book through online, so that it is added to my library. So in the same way, if you also buy this book, it will be added to your library, and then you can refer this book, right? So whatever the syllabus is there in Virarajan book and in this book is covers in a nice manner. There is no deviation in that, right? But uh, as far as the level of difficulty is there, that is, if in a book topics are there, but if it is a second year student study, then how much has to teach? So that is there. So for that, you should follow the class notes, all these things. So whenever I taken a class, I recorded the class. So the recorded video of the live class, what I am taking now, will be shared with you in the GCR, right? After the class, maybe on that day and the next day, I will put my video lecture, that is the Google Meet video lecture link to you, so that you can watch whatever you see in the class, you can watch there again and you can understand. Still, if you have any doubt, you can ask me in the next class, right? Okay, so I will ready to help you academically in all manner. Only thing is you have to use the things in a proper manner, right? You should not do any unnecessary things, just like joining the class and moving out of the class in between. So now what 2 or 3 people I can manage, but once after 1 or 2 weeks, definitely 30, 40 people will be there. So in between, if you coming and going means not good, right? So today I am not using Google attendance. I will use the Google attendance also. So that live Google attendance will check who are the people are online or offline, right? So that keep that in your mind, right? So at least I expect all three of you will attend all the classes, right, without any fail, right? So can you able to see this book,
Yes, sir.
right? So this is the book Transforms and Partial Differential Equations by these two authors, experienced authors only, and a nice book, and there's no just printing mistakes, right? It's everything is okay, and the publisher also a very good publisher, right? So you'll get, if you possible, you can get this book, right? Where that partial differential equations by Chiraraman Krishnan Das and Vijay Kumari. It is Pearson publication, right? It is available as a e-book in Amazon also, right? So now I start my class with the basic things, right? So first thing I want to tell to you about, right? Can you see the whiteboard? Now everything is white,
Yes, sir.
right? So this is the manner you take the class. So you will get everything in a nice live manner. So only thing, you just follow me. If you have any audio video difficulty, you can tell me, right? Suppose if I am not audible, then you can tell me, or if you are unable to see the picture, then you can tell me, right? So now the time is only 12:30, I think. So we still have half an hour time. So I just tell you all the basic things. The next 20 or 25 minutes. I'll tell you all the basic things in the next 20-25 minutes, right? So, but it is an interactive section, because first, always at the first class I always interact with the students, right? So I am start from very basic thing, right? Differentiability, integrability concepts are based on certain things, right? So basic things I will tell. First thing, a number system, that is very, very important, right? So do you know what is the simplest number system? Anybody? Anil or Surya? Do you know what is the simplest number system? Anybody? Simplest set or number set? Rational number, irrational number, integers. So in that manner, what is the simplest, smallest number system? Do you know? Anybody? Say yes or no?
No, sir.
Right? See, this the simplest number system is the natural number system. Counting numbers. So when man know how to count, that is the simplest number system. 1, 2, 3, 4, 5, and this keep on going. Right? So this is called natural number system. Right? They use scriptian to denote this number system. Right? So after natural number system, do you know what is the next number system? Anybody? I'll give you only 10 seconds time. Do you know about whole number system?
Whole numbers. Yes, sir.
What is whole number?
So 0 to 10.
If you include 0 also, then it become a
Whole number.
whole number system, right? So number system is the natural number system is there. If you include 0 also, then become a whole number system. Then
Integers.
integers, right? So integers is denoted by zeta, z, right? Not I, it is denoted by zeta. Some book they use I, but okay, whatever, maybe no problem. So what are integers?
From minus.
If you add the negative values also in this set, then automatically it become a
Integer.
integer set, right? So natural number system, whole number system, integers. One thing you should know, natural number system is a subset of whole number system. You can put this inside this, right? Similarly, whole number system is a subset of
Integers. Integers.
right?
Integers.
Okay. Next, what is the next thing you know? Integers is a subset of
Rational numbers.
rational numbers. What is rational numbers? Rational numbers denoted by the letter Q. What is rational numbers?
Fractional numbers.
Fractional numbers. So if you include, right, any P by Q form where P and Q are integers, right? where
Yes,
any
sir.
P by Q form, where Q is not equals to 0, where Q is not equals to 0, where P and Q belongs to where? P and Q belongs to the integer number system. Right? P and Q belongs to the integer number system. Right. Okay. Then much bigger. So we started with natural number, whole number, integer, rational. The next,
Irrational.
irrational. Okay. So whether the rational number is a subset of irrational number, here
Yes,
you
sir.
can put natural number is a subset of whole number. Whole number is a subset of integers. Integer is
Integers.
a subset of rational number.
Rational numbers.
Can you say rational number is a subset of irrational number? Rational number is a subset of irrational number. True or false?
False.
False. Why? Why? Why it is false? Do you know why it is false?
No, sir.
No, sir.
Then do you know what is irrational? You tell one example of irrational number. One example of irrational number. One example of irrational number.
Root, sir.
Root 2, right? Root 2 is a root 2. What is root 2? You write to 1.414, right? Approximately, right? Remember, you can write root 2 as 1.412 approximately, but it's not exactly equal. So what is irrational number, right? So irrational number don't have any thing, but IR, you can put IR, irrational number. So irrational numbers are the numbers cannot be written in terms of rational numbers, right? In other words, if you write a irrational number, right, just like something like 4.323 and so on, right, and so on. If this doesn't follow any pattern or if there is any repeatance, then this number is called as irrational number. The difference is 1 by 3 is a rational number. Why 1 by 3 is a rational number? It is 0.33333, right? So it is unending. But even though it is
Yes, sir.
unending, we know, right, what is the pattern it has. What is a pattern it has. So similarly, if you see a number 1.23232323, right? If you see this number is also a rational number, because even though it is unending, but still we know what is the pattern of the number, right? So in that case, right, so it is just a pattern or it is a repetition of numbers, then it comes under rational numbers. But irrational numbers are the numbers, it doesn't have any repetition, it will keep on going. So the classical examples are pi, right? So pi is, you are writing 3.14, right? So 3.14 is only a 2-digit approximation of the irrational number, right? So 3.14 can be written as 314 by 100, right? In that case, you can say it is a rational number. It's not like that. This is only a approximation because we don't know 3.14 and it is keep on going and there is no pattern in the series. It is keep on going, so that this type of non-repetitive and non-pattern, right, numbers, right, are called as irrational numbers. But numbers like this 1 by 3 or 1.2345, 2345, so even that numbers having a never ending, but still we know there's a pattern in the series. That series means I am telling how the numbers are moving. So if you know the pattern, then it become a rational number. But if you don't know pattern, then it become a irrational number. Right? So there is no connection between rational and irrational. If a number is rational, it won't be irrational. If the number is irrational number, it won't be a rational number. but all your whole number system, integers, and all this comes under inside rational number system, right? So you forget about integers, you forget about whole number system. So now you just only remember rational number and irrational number, right? Only these two things. Rational number means, right, all the numbers. Even you can write an integer using rational number. You can write 3 by 1. It looks like rational number, but it is an integer, 3, right? So you can write all the whole numbers, integers, in terms of rational numbers. So a rational number is the biggest set. Apart from the set, the complement set, that's like A or A complement, right? So complement of rational number is irrational numbers, right? Okay. So now, yeah, we have two big sets. One is rational number set, another one is irrational number set. Now, right? So do you know about real number system? Do you know about real number system? Surya? Are you able to hear me? Surya and Syed. Surya and Syed. Surya? Syed?
Yes.
Are you able to hear me or not? Are you able to follow me or not?
Sir. My mic didn't work, sir, for a minute.
Surya? Right, can you tell me what is the real number system? What is a real number system? Anybody? Say yes or no. You know me, so I will explain.
Yes, sir.
What is real number system?
All the numbers from numerator
all the
to
numbers, right?
irrational numbers.
So, when you draw in schools, you draw a real line in a graph notebook by minus infinity to plus infinity. Do you remember? Right? So when you draw a real line from minus infinity to plus infinity, you are thinking that it has all the numbers, right? So union of rational and irrational numbers. Union of rational and irrational numbers. So if you join both rational number and irrational number in your set, right? So this is Q is rational number union with irrational number. If you join these two number system, you will get real number system. Real number system. Right? So union of rational and irrational number will become a real number system, and that you do in all your schools in graph notebook. You put plus infinity on one side and you put minus infinity on other side and put 0 in the middle and you put 1, 2, 3. But remember, it is not only 1, 2, 3 and minus 1, minus 2, minus 3, right? So in between 0 to 1, there are infinite number of real numbers are there. Similarly, between 1 to 2, there are infinite number of real numbers are there, right? And here also there are infinite number of real numbers are there, right? So now I ask a simple question, right? What is a real number after 0? 0 is a number, right? You know 0 is a number, right? 0 is a number. What is the next real number after 0?
0.1.
If you say 0.1, I can say 0.001. It is in between 0 and 0.1. Can you able to tell me what is the next real number? If you ask whole number means you can tell after 0 in the whole number system 1 will come. Even in integer also after 0 1 will come. But I am asking in the real number system. What is a real number after 0?
0.0 bar 1.
The thing is, you can't say. You can't
Sir.
tell. You can't tell because, right? Nobody can tell what a real two consecutive real numbers. Two consecutive real numbers. Now only, right? Remember, now only the concepts like, do you know limit concept? Limit concept.
Yes, sir.
What is limit? So if I say a limit like this, a limit x tends to 2, if I tell x tends to 2 of x square of the function f of x is equals to x square is what? When limit x tends to 2, what is the value of x square?
X is equals to 0, comma x is equals to 1, comma x is equals to 2. You should put the value, sir.
When limit x tends to 2, what is the meaning of that? X tends to 2 means not equal to. Remember, I am not putting x equals to
Equal.
2. I am putting limit x tends to 2. What is the meaning? This you already studied in your lower classes. This is the base. Limit concept is the basic concept for continuity. From continuity only, differentiability is coming. Right? What is the meaning of limit x tends to 2?
Its value can be within the 2.
The meaning is, right? The meaning is, right? Remember, I can draw here. Right? This is your x-axis. This is your y-axis. Y-axis is nothing but f of x. Right? What is x square? X square is nothing but the parabola. Do you remember? X square is nothing but a parabola. This is f of x equal to x square curve. Right? So here, when x is equal to 0, y value is also 0. When x value is 1, when x value is 1, y value is also
1.
What is the y value? When x is 1, f
1.
of x. F of x means f of 1. F of 1 means 1 square. 1 square is 1. Similarly, when x is 2, when x is 2, f of 2. F of 2 is 2 square. That is
4.
4. Right. So as a function value, you know when x equals to 1, function value is 1. When x equals to 2, function value is 4. Similarly, when x equals to 3, what is f of 3?
The function value is 6.
9.
3 square, 9. So function value you know, right? Function value you know. But what is the meaning of limit? I'll just explain you, just listen. What is the meaning of limit? Limit means when x moving, when the x value moving towards 2. Towards 2 means it is somewhere nearer to 2. X may be 1.99999. That is also a number very nearer to 2. Or x may be 2.000001. So whether it is on the left hand side or in the right hand side, x approaches 2 or x limit x tends to 2 means x is a value very nearer to 2. When x is a value very nearer to 2, what will be the value of f of x? Asking when x is approaching 2, what value you can expect for f of x? That value you have to put it as limit value. Can you tell me by this graph what value you can expect? By this graph, what value you can expect? Anybody? When x approaches 2, suppose x is 1.99999, f of 1.999 is nearer to, what will be f of 1.999? It is something around 3.999, right? Do you understand? Suri and Sayed.
Yes, sir.
Similarly, on the other side, suppose f is 2.0111. Then what value? It will be 4.0001, something will come. Right? So whatever may be the value, since the graph is a continuous one, whenever if you take a value nearer to 2, the function value is nearer to what? What you have seen? What you get from 3.999 and 4.001? These two numbers nearer to
2.
Nearer to 3.99 and 4.001. Both the numbers nearer to
4.
4. Right? So now you can write the limit value as 4. Right? So remember, here 4 is not the function value. 4 is a limit value. When x approaches 2, you have f of x approaches 4. F of x approaches 4 because the function value is f of x equals to, function is f of x is equal to x square. Right? Okay. Now listen carefully. I will just erase all these things and once again. Now I will give you another function. Define a function like this. F of x is equals to x square, or f of x equals to 5 when x equals to 2, and f of x equals to x square otherwise. Otherwise means for all other values f of x equals to x square, but at x equals to 2 the function value is 5. Then what will be the graph of this? The graph will be like this. Meaning is, right, when you x approaches 2, this is 2, right? X approaches 2, right? F of x approaches that x, when x approaches, for this also, when limit x approaches 2, f of x approaches what? F of x approaches what? Now you tell me. Now, do you know what is the difference between this function and the previous function? What is the difference? Surya and Sayed, can you tell?
They have given the equation in this, sir.
See, previous function is a continuous function. Previous function is a
Continuous function.
But this function is not a continuous function. Why it is not continuous? Because at the point x is equals to 2, at the point x equals to 2, the function value jumps to 5. Jumps to 5. So you know in schools they tell continuous function means you have to draw the graph of the curve without lifting your pen. But here you have to lift your pen and you have to mark x equal to here and then you can continue from here. Right? Now you tell me what is the value of f of 1.999? For this function. We have only 5 minutes time, so tell me.
X square.
Still we have to use only x square because only for x equal to 2 the function value is 5. So for 1.999 it is still 1.999 whole square only. So in that case, what will the value? It will be something 3.999. Right? 3.999. Similarly, what is the value for f of 2.001? For this also you have to use only the x square. Because only for x equal to 2 you can put 5. For all other values it only x square. So it is also only 2.001 whole square. Again it is 4.0001. Now tell me what is the limit of this function when x approaches 2?
5.
Not 5, it is 4.
4, sir.
Because what is the meaning of limit? Limit concept is not equals to. When x approaches 2, when you take any number nearer to 2, whether it is 1.99 or 2.002, where the numbers are, these two numbers are nearer to
4.
Limit value exists, right? Limit value exists. It is 4. because when he approaches x equals to 2, the left side number and right side number shows it goes towards 4. But unfortunately, when you see the function, what is the function value at 2?
5.
5. So
Yes.
this is an example where limit value exists, but it is not equals to what? Not equals to
F of 2.
function value.
Value.
Limit value not equals to function value, right?
Value.
This is an example for discontinuous function. If a function is a continuous function, means the limit value should exist and the limit value also should be equals to the function value. Then only the function will be a continuous function. Then the function will be a continuous function, right? So whatever we have seen in the first example, that is a continuous function, because there the limit exists and limit value is also equals to the function value, that is f of x to x square. So we call that previous function is called a continuous function. But in this example, limit exists at the point x equals to 2, but the function is not continuous at the point x equals to 2. Why? Because limit value is not equals to what?
Function value.
Function value, right?
Function value.
Right. So now I'll give you one simple example where the limit itself doesn't exist. Right? Only 1 minute I will just give you an example of where the function, the limit itself doesn't exist. Only 5 minutes more is there, so I will just. Okay. I'll put f of x equal to x square when x less than 2. F of x equals to 5, x greater than or equals to 2. Right? So now you just see what is the graph of the curve. Up to x is equals to 2, it looks like a nice parabolic function. Once it reaches 2, it jumps to 5. Thereafter, the function value is only 5. So up to 2, that is before 2. Before 2, the function value is, right, x square. That is the parabola. But after 2, the function value jumps to, so here
5.
Y value is 5. Right? So it jumps from 4 to 5. Thereafter, whatever may be the x value, the function value is only 5. So it is comes like nicely here, then it jumps over here. Right? Now tell me what is f of 1.999?
X square.
X square. So it will be something 3.999.
999.
Now what is f of 4.001?
5.
5 only. Because after 2, whatever the number, 4.001 or 5.001, whatever may be, the function value is 5. Right? Now you tell me what is the limit x tends to 2. Sorry, it is 2.001. Even if you take 0.001, it is only 5. What is limit x tends to 2 of f of x? You will end with this. When you approach from the left hand side, that is 1.99 is the left hand side of 2. What is the value? 3.999. It is nearer to 4. It's nearer to 4. When you approach the right hand side, what is the value of y?
5.
5. Right? So what is the left hand side? When you approach from the left hand side, limit value is 4. When you approach from the right hand side, limit value is
5.
5.
So in this case, left limit is not equals to right limit. So the limit doesn't exist. Limit
Doesn't
exist
exist.
means limit should exist on both sides. and both should be equal. So in this case, limit does not exist. Why? Left limit exists because when you approach left side, it's called left limit, right? So 3.99 is called as left limit. When you approach from the left hand side, it moving towards one number, that is 4. Okay, that is called left limit. But when you approach from the right hand side, it is also approaches some number, that is 5. But left limit is not equals to right limit,
Right limit.
so that limit does not exist for that particular point.
Exist.
Right?
Yes.
So there are some
Yes,
worst
sir.
cases there. There, left limit, right limit itself doesn't exist. So that is the worst case scenario. So now I summarize. Right? So when you say a function is as a limit, it should have left limit and it should have right limit, and both the limit values should be same. Then only limit exists for that particular function. When you say some function is a continuous function, the limit should exist for that function. Not only the limit exists, the function value also equals to the limit value. So if the function value is equals to the limit value, then you can say the function is continuous at a particular point, right? So number system, limit concept, continuity concept, these basic 3 things are there. And here whatever the x we are showing, x is always a real number. X is always a real number. X is not a whole number system. X is not a natural number system. X is a real number system.
Real number.
It has all integers and it has all rational and irrational numbers. There is no gap between any two irrational numbers. It is a continuous process. It is a, so that we are changing. It is approaching 2. It is approaching 2 means there is no gap. It is keep on moving towards 2. There is no gap in the real number system. It is keep on moving towards 2, both the left hand side as well as the right hand side. In both the sides, if it moving towards a particular number like 2, if the limit exists and both the limit are same, then you can say that the limit exists for that particular function. And if the limit value is same as the function value, then we can call it as function is continuous at a particular point. So limit concept, function, continuity concept, differentiability concept, all these things defined on a particular point. You can't simply say function is continuous. You can say function is continuous at a particular point. If that point is a general point, if that particular property is true for all points, then you can say function is continuous at all points. Otherwise, all the definitions are based only on